All right, so Rust macros. Everybody's afraid of Rust macros, but they're not that bad. So real quick before we get started, I wanted to say that in order to prevent a lot of really jarring transitions between this presentation and the code editor, I'm going to be spending a lot of time in the code editor after I get through sort of the initial content. But everything I talk about in the code editor, there are slides for it that I've disabled, but I'm going to send out the slides later and you can look at them at your leisure. All right, so what is a macro? A macro is an abstraction of code generation. So that means that it's a system inside of Rust that generates more code. They operate on syntax trees. They don't operate on plain text, but they don't operate on Rust syntax trees. They operate on sort of something a little bit before Rust called a token tree. A token tree is a minimal syntax that was designed to always be compatible forwards and backwards with any version of Rust. So the idea is that, think about a couple years ago when they first introduced async await. That's a compatibility break, right? Because now if you have any variables that are called async await, those are keywords now. You can't, those don't, those will break on future code. So in order to make it so that macros didn't break every time a minor change happened, they created something called a token tree. A token tree is a single token tree is one of four things. It's identifier, like foo or match, right? So it can be if, it can be for, it can be any language keyword, anything that's a word, right? Just a plain word that you would see in the language. It can be a literal, like just a number or a string literal or a character literal or any kind of variable literal. It can be a piece of punctuation, like an equals or a question mark. Every individual piece of punctuation is parsed as a single token tree, but they retain some information about spacing so that it later, when you're trying to figure out if it's a double equals or two equals that are far apart, they can figure that out later. And finally, and most importantly, it can be a matched set of braces. So parentheses, curly braces, or brackets. The braces can contain any other set of token trees recursively, but it's all considered a single token tree. This whole system right here is, if there's one thing I want all of you to take away from this presentation, it's this idea that macros operate on token trees. They take token trees as input, they spit out token trees as output. At no point is Rust, the language, the syntax, ever involved. It's only after all the macros get done with everything that the Rust compiler comes in, looks at the syntax trees that have been finally created, and parses them more specifically as Rust syntax. There's a lot of kinds of macros. We're going to be talking about macro rules macros, which are the kinds that you see all the time. Macro rules macros use a pattern matching system to match an input set of tokens, transform them into an output set of tokens, and spit it back out again. But it's worth noting that like derive is done by macros, for example. So when you see derive clone, there's a macro called clone that's generating a clone implementation. Serde uses a lot of this kind of macro, and so on. They're all macros. But for our purposes, we're just looking at macro rules because those are the fun ones that you see all the time. All right. So let's look at a basic macro. This is a useless macro called 1+1. All it does is take precisely 3 identical tokens, one a literal plus a punctuation and one another literal, and spits out a new token called 2. And that's all it does. We can see that in our editor. So if I write that out, we'll call it 1 plus. We say this takes out 1+1, and it always spits out a 2. We can run this macro pretty easily. And we'll see that this passes. Right, everything looks good. Now, we can actually look, as a quick side note, Rust Analyzer gives us the ability to see what's happening in this macro. If you run this little command called expand macro recursively, we can see that this macro expands to just a 2, like literally just the 2 token. To reiterate again, this is not, when the macro gets done with it, it's not Rust. It's just a 2 token. And then the Rust takes that 2 and turns it into the number 2. We can see that this macro will fail if we put anything else into it. So if I put a 2 here, it's going to say, nope, can't do that. did not expect to see a 2 here. No rules expected this token. Macros can have more than one pattern, though, so we can fix this by adding something else. We can add a 1 + 2 pattern, right? We can say this is 3. Now we're happy again. Now this file passes again. No, it doesn't. What's wrong with this? Oh, because our assertion failed. There we go. Great. And again, we can see if we expand it recursively that this expands to a 3. So that's part 1, right? You have your input patterns and you have your output patterns. The macro rules will try each pattern in order until it finds one that matches, and then it'll just use that one. This is useful for like disambiguating stuff. You can have a specific pattern at the top and then a more general pattern near the bottom. All right. So obviously we don't just always want to have a fixed set of tokens. We want to have some kind of user input. And for that, we use something called a metavariable. A metavariable is indicated with a $, and it always has a type. So in this case, we can say we'll match some kind of value, and we'll say it's a literal, right? And we'll say in the output, we're just going to reverse these things. We're going to say we want to have $value plus 1. So now, if we run this again, even though 2 is a literal, we'll see that it matches the second rule, right? It's still going to pass. We're going to expand it again, and we'll see it's a 3. If we put something else in here, though, like a 5, it's going to match the last rule. This is going to sum to 6, so this will pass. But when we expand it, we see it expands to 5 plus 1, right? It took our value literal, put it here, pasted these tokens in, and spit it back out again. What's important here, I know I keep harping on this point, but it really is like the thing that I would recommend if you're really confused by macro to keep coming back to this idea that what we're operating on here is tokens, not Rust syntax. If I put something valid here, like let's say let value, or let's say let num equals 10. If I put num here, even though num plus 1 is valid Rust syntax, this is going to fail because num is not a literal. Num is an identifier. So if I try to run this, it's going to say, nope, did not expect to see an identifier here. Was looking for a literal. So the macro will fail. On the other hand, I can do something that the macro thinks is valid, but that Rust thinks is not. If I put hello here, this is fine, right? This is a literal. This is a literal. That matches this pattern. It's all going to come out fine. So this is going to evaluate successfully. And we can see if I try to expand it, it expands to hello plus 1. And then immediately afterwards, we're going to get a compile error, right? You can't add integers to strings. Don't like that. Cool. So that's the basic idea, right? You have your metavariables. They have types. Let's talk about those types a little more. In the Rust macro system, there's about a dozen types. The list is always available in the language reference guide, to which this is a link, which you can see later. In my experience, there's about 4.5 really important ones that you want to keep in your back pocket. There's literal, which we've already seen. It's any Rust literal. There's expression, which matches any Rust expression. And that can be more than one token. So your metavariables frequently will match a lot of tokens. So expression matches any valid Rust expression. Ident is a single identifier, right? And tie is any Rust type. These are the ones you see pretty commonly. There's a bunch of other ones too, but these are the ones that we like the most because these are the ones that are sort of the most obvious what they do, the most common to see in actual Rust code, and therefore the most common ones to be pushed around by macros. The other important one is called TT. TT stands for token tree. It matches any single Rust token tree that we saw earlier. So this matches any identifier, any single piece of punctuation, any single literal, or any single set of matched braces as a single token, right? So parentheses, and then anything inside the parentheses, and then a close parentheses, including additional nested parentheses, and all the nesting happens automatically. So for these types that have more than one token, so expression can match several tokens, a type can match several tokens. Rust will match those greedily. It'll always match as much as possible. And therefore, in order to make sure that it's always unambiguous, those types always have some kind of some set of terminators that are allowed. So for example, an expression has to end with a comma or a semicolon or a arrow or something like that. Type has a few more that it takes. I don't remember the set again. Once again, the list is always available to reference. But that's a common sort of thing you'll see that Rust will get mad at you about. You have to end your fun metavariables, right, expression or type, with some specific terminator character. All right, so that is everything we need to know to make our first sort of real macro. And what we're going to make is try. Those of you who were around several years ago remember that try was the precursor to the question mark operator. So this is a macro that does the same thing as question mark, right? It returns the value if it's okay, or it resolves to the value if it's okay, or it returns from the function the error if there's an error. And that, as you can imagine, is actually pretty easy. So we match any expression, right? Our value is any single expression. We match over it. We say if it's okay, we keep that. We say if it's an error, we return it. There you go. And for a long time, this was the try macro. So in practice, it would look something like, we would say let result equals, let's make it something obvious, right? Okay, 5, and then we'll say let x equals try it result. And we gotta return okay. You run this. Great, it succeeded. So we can see that this macro is the same as the what we all love now, the question mark. Oh yeah, that's not okay. This gets you about halfway there, right? You can do a lot of useful stuff with just this, just matching individual values or several values or whatever you want in these patterns. But obviously, we want to go farther. We want repetitions. So in addition to matching individual metavariables, individual tokens, or individual kinds of sets of tokens, we can match repetitions. So as an example, we're going to make a macro that prints a bunch of lines. And it takes a bunch of expressions and prints each one on a single line. A repetition is delineated by this $sign question mark thing. It looks like this. Inside of it, we put whatever pattern we want. So we can say, here's our line. It's an expression. And we also have to end with a comma. So we'll say then a comma. So all we're saying here is we want to match an expression followed by a comma, and we want to match any number of these. Rust accepts sort of the classic regex operators. So star means 0 or more, plus means 1 or more, and question mark means 0 or 1. Other than that, they're all treated the same, though. On the output side, we use the same syntax to unpack a repetition. So we would say, we want to print a bunch of lines. So we'll say print line. We'll say for each repetition that we have, right? So there's our dollar parentheses with our star. We're going to print line, the line. Great. So now in main, we can print a bunch of stuff. So we can say print line, print lines. We'll say hello. We'll say world. And we'll throw some numbers in there just to show that we can do any kind of expression we want without any kind of typing concerns. And there we go. If we run this, we see that it's going to print all this stuff on all these lines. Once again, we can use that great thing. We can expand the macro to see how it looks afterwards. We're going to see something fun here, though. So print line is also a macro. So what happens here when print lines is resolved is that it outputs all of these tokens, right? And this, as far as the macro is concerned, is just some more tokens, right? It's an identifier, a punctuation, and then some parenthesized stuff. Once it gets spat out, the macro resolver goes again, and it just keeps sort of going in a circle until all the macros are resolved, and we're left with plain Rust code that looks like this. So here's all of our print lines. Here's what print line looks like in the real world. We should all be very grateful that we don't have to deal with this in practice. Here's our individual, here's our individual strings and our text, and so on. We can obviously do 0 of these, right? If I get rid of all this, this still works because the star accepts 0 things. Great. All right. What we don't like though is this comma here, right? It's nice. We want to. We sometimes want to have the comma, but sometimes we don't, right? We want to be able to write this. If I write this though, it's going to say, "Oops, we were expecting to see a comma here, right? We found an expression, but the pattern now calls for another comma." It turns out that Rust supports this automatically. So if we put this comma here, outside of the parentheses but before the star, it's now sort of a part of the repetition, and it's saying any number of lines separated by commas, right? So the commas are only going to show up inside of the thing. We save this. This is good again. We print it. There we go. Great. So when you see this sort of a syntax, when you see some sort of character here between the parentheses, the closed parens, and the star, that's what it means. We're doing a separation. And finally, we want to be sort of maximally Rusty. We want to match what Rust lets you do, and Rust lets you do an optional trailing comma, which is pretty easy. We can use our 0 or 1 of repeater, and we just put a comma in there. We say, all right, there's an optional comma at the end of this thing. So now if I put a comma back, it works again. Great. At this point, this is pretty much everything you need to know about macros. That's it. Everything else is an elaboration on these ideas. Everything else is just mixing and matching repetitions, mixing and matching metavariables, mixing and matching different kinds of patterns at progressively higher levels of complexity to do whatever you want. Are there any questions so far before I move on to the next part?
Can you count? Like when you're matching all those lines, can you get the nth line or know what line you're on? It's
a good question. Macros do not on their own support that, but you can just sort of do it yourself. So let's say we wanted to, at the end of this, print how many lines we found. Well, the only thing we have the power to do is expand some kind of syntax a repeated number of times. But what we can do is we can sort of cheat. We can say, all right, let's do, I can't hear myself. Hold on, sorry. There we go. I muted myself, I'm sorry. So let's say we want to print line. All right, so what's our count? Well, we know we have to repeat something, right? That's the only way forward. And we know we have to tell it that this dollar line is what we're repeating. We can do something kind of clever though. We can just say, here's our dollar line. It's a no op, and then here's a 1. Right. So this whole block right here is now an expression that ignores this and resolves to the number 1. We can then add them all together, and then at the very end throw down a 0. At the very front, we'll say this is a count. And we should be able to put that right there. We should be able to remember to put a semicolon after it and an exclamation point. There we go. If we run this, we should see a 5. There it is. There's our 5. And to show you how it works, we can once again use our lovely, lovely expand macro to see what's happening. So we can see that what's happening here is we have, hello is a no-op, 1 plus 1. We're just right, here's all of our 1s, and then at the very end a plus 0 in order to make the expression resolve correctly. So this is sort of ugly, right? But the optimizer is going to get through with it, right? It's going to get rid of all of these, pointless statements and collapse the whole thing into a single constant. So that's sort of the trick. For more complex stuff like that, typically you'll make sort of a helper macro that takes some kind of repeated input and does something simple or something does some sort of utility with the input. Anything else? Other questions? Nope.
Is that comma asterisk, like for the trailing comma, is that relatively new? Because the one tutorial I saw, basically they duplicated the entire match, and one had a comma and one didn't, and I was like, it was very unpleasant.
Yeah. So this is not new. This has been here forever. This is new. The question mark operator is actually pretty new. So previously, the only ways to do this would be to do something wrong, like to put a star here and say, all right, we can have as many commas as we want, right? Or you would have to use several patterns, right? So you would make another pattern, but put the comma on the inside, right? And we said earlier that it always picks the first one that matches. So this one will fail, and this one will succeed. Obviously, this is hideous, but that was sort of the best. That was sort of the best you could do until the question mark.
Thank you.
Yep. Cool. Anything else? All right, great. So let's move on. Before we do something fancy again, I wanted to take a brief detour into a real world example that I actually put into the real Rust standard library a few weeks ago. So our problem statement is this. We have our write interface for writing things to files or whatever. And it's a function that takes a buffer, right? Takes a slice of bytes and returns a result. If it's an error, we know that no bytes were written and there was some kind of error. And if it's okay, we know that exactly that many bytes were written. Now, what we want to do is we want to shave off that many bytes from the front of the buffer because we are chaining together several writes in a single function. And we want to very easily be able to say, all right, so write, the front of the buff, and then if only some of it got written, slice off that front and process the tail of it. Additionally, we also want to have this work for infallible writes. So there are some helper write methods that can never return an error and therefore always return just a size instead of a result. So what we want, and because we're doing this so often, we want to condense it into something, a simple kind of pattern. Version 1 obviously is a function, right? There's nothing especially macro-y about any of that. So we could write our function, right? We could write our write tail, and it takes a buffer. And it takes some kind of write function, right? Because we have to be generic over whatever we are writing to. So we'll say this is a function that we're going to call once. It's going to take a buffer. It's going to return the result that we wanted. And then from this helper, we are going to get our tail, right? So we're going to return a result of our tail. Great. And it's not a hard function to write, right? We perform our write operation, and then we do our slice. Am I still in a macro space? That's what's going on here. Yeah. This is fine, and this is actually what I did first. The problem that I had with this is that it ends up being sort of weirdly boilerplatey, right? So if we have our standard out, let's say we're writing to standard out. And we're, and we have our buffer, right? So we have let bytes. So to get our tail, we call the function. But now we start repeating this a lot. We start repeating this token, right? This variable, and then here on the end of it, we're gonna put it into our call. So this is fine, but again, I found this sort of aggravating. Additionally, how do we do it for our infallible write? How do we do it for the one that returns just a usize, assuming we want to use the same function? Well, because we are forcing ourselves to return a result, the only way to do it, right? So let's make our prototype here. Write to buff, taking a buffer, returning always a usize. If we put that in here, well, it needs to return a result. So we just have to unconditionally make it okay. And then on the other side, return an error that we're never going to see. Don't love this. Can we do better? Obviously, the answer is yes. We can do better with a macro. And to do better as a macro, we have to think about sort of what it is that we are, what our operation looks like. And our operation always looks something like this. It always looks like we have some kind of object and we're calling write on it and we're giving it some kind of input. Well, this is a pattern. So we can feed this pattern to a macro. So let's do it as a macro. Macro rules write to, or see, let's call it write tail. Yeah, write tail. So, we could just take any expression here, but what we want is to get this buffer. We want to sort of capture this on the way in so that we can slice it on the way out. So we'll define our pattern. We'll say that our write, and to be generic, we'll say maybe we have any number of chained dots. So we'll say we have a write function separated by dots, and there's at least one, right? And we have to make this an identifier. So we have any number of identifiers separated by dots, and there's at least one of them. Then we have some parentheses, just some regular parentheses for a function call, and we have our buffer, which is any expression. Great. At this point, we can kind of duplicate what we've done up here, right? We can say we're going to use an extra set of braces to make sure that all of our scopes work out correctly. We'll say let written equals, we're going to unpack our write statement, $write dot plus, right? So the same thing. You can use this dot syntax on the outgoing side as well, where this means the same thing. Repeat this write, separate every identifier with a dot. Parentheses for a function call, put our buff in there. There's a common C macro problem that you can run into in Rust as well, which is that if buff is some kind of function call instead of just a single literal or identifier or something, every time we put it in here, every time we put this $sign in here, it's going to do the entire function call over again. So we want to make sure that we only do that once. So we're just going to go ahead and do that early. Great. Put that in here. And we will resolve to, we're just going to, so this point is a result. We don't necessarily want to do a question mark at this point. So we'll just do a mapping instead. Result.map. Written. Great. This works. And so if we put this here instead, right, we can say let tail equals write tail. And now instead of having a whole closure thing, we can literally just write what we were going to write before. Standard out dot write buff. Throw a question mark on the end. We'll use the right variable name. Great. And this all worked out. And tail we can see here is a U8. All right. So what we've done here is we've done something slightly more complicated than what we had originally to save us some keystrokes here at the bottom. Which already is good because if we're doing this a lot, it's nice to be able to sort of compress it like this. But we can go a step further. So you'll recall earlier one of the problems with this version was that if our write is infallible, we have to sort of push it through this result shape and then unpack it on the other side. With a macro though, we can just figure it out. And we notice that we always are using we're always using a question mark here, right? In our actual use cases, we're always just returning the error right away. So we can move this question mark to the inside as a signal to the macro of which version we're using. So if we come up here, we say this version has a question mark. This is our fallible version. We can put the question mark here to return it, right? This is now just written. And we can return our buff. Cool. This still works. But now we can do a second pattern. We can get rid of our question mark and put something, and we can get rid of our question mark here. We can get rid of our question mark here, and we can say, all right, so this bottom version with no question mark, we're now assuming that this write is infallible. It's always going to return some kind of U size, and we're going to spit this back out. This works really well. So because now down here, we can say write tail. This time we're going to use our write to buff, our infallible version. Right, to buff our tail. Great, there we go. This to me is sort of the ideal macro where it's pretty simple. It's solving one specific use case. It's using the power of the pattern matching that you get to express something very succinctly, that still, you know, is Rust code, right? This is just a Rust function call, as far as we can tell. Even though the macro doesn't think so, the macro just sees a bunch of tokens. But we see a Rust function call, we can sort of interpret this as being, oh, we're calling this function, but then this macro is aware of this input parameter and can slice it at the end. And if you're not convinced, obviously we can expand this once again, and we can see that it's just doing exactly what we expect, right? We have our assignment, we have our function call, and we have our select. All right, cool. Let's talk about just some other ideas about repetition. One question I did not hear, but you might have, is how can it figure out? Suppose you had some kind of repetition. How does the macro? Suppose you had more than one repetition. How does the macro figure out which repetition to use if you have more than one? And the answer is entirely from context. So let's say we have some kind of silly function here that prints a bunch of stuff on lines, but also groups them into pairs for some reason. So we can say we're going to take here's our thing one, any kind of expression separated by a comma, and then a semicolon, and then another set of expressions, right? Dollar thing, expression, comma, star. So we have we'll say this is thing two. So we have two sets of repetitions here, right? We have one that takes thing one that takes thing two. How does Rust figure it out? Well, it just figures it out from context, right? So we can say we're gonna have some prints up here, println dollar thing one star, and then another one. Great. Great. So when we're spitting out our repetitions here, Rust just sees, oh, this is thing one. That is the thing that we are repeating this repetition over. Down here, thing two, right? Thing two is what's inside of this repetition, so that's what we're going to expand over. So if we run it, you know, we'll say, so here's some groups up here, and then a semicolon, and then here's some more groups. And then we'll never do that. And we'll get rid of this. And we won't get rid of too much. Great. So here's our same print that we had before. So you can see that it's just picked out the correct ones. Another cool trick, you can reuse metavariables inside of repetitions that they're not already a part of. So let's say we wanted to do some kind of greetings, right? We wanted to say greetings, and we're going to say here's some kind of greeting, and we are going to greet a bunch of people, right? We can use this greeting variable, this greeting meta variable, I should say, inside of this repetition. And it's just going to get repeated once per repetition, right? So as we are unpacking this repetition with this $person thing, every time we repeat it, we're just going to insert a duplicate of this greeting. So when we do it, when we say, you know, we're going to greetings, and we're going to say hello, and then we'll say Nathan, and we'll say Dave, and we'll say Taylor. And then we'll put a semicolon where we need to put a semicolon. And then we will, oh yeah. So yeah, this is a good point to make as well. Whatever is inside of these curly braces is what will get pasted. Because this expects to be an expression, when you have a bunch of statements like this, often you want to throw a second set of curly braces in here, because the second set will actually get put in there and the whole thing will get boxed into into curly braces, right, like this. If we run it, there's all of our greetings, right? So it repeated the whole expression every time. Cool. What else? We can nest repetitions. Nesting repetitions is where you start to see a lot of like generating types over and over again, because you can have a list of types, and then inside of that type, you can have a list of fields, right? So let's say we wanted some simple enumerations that have a print function attached to them. So we'll say we want any number of enums, each of which has a name, which identifier. And then in curly braces, we want to have any number of fields, also identifiers. Great. So we have a nested repetition here, right? So we have this one, which repeats with the name. And then for each name, we repeat a bunch of fields. Great. And then we have to make sure we throw a comma. We don't have to put a comma here, which is fun because identifiers are always a single token. But it's nice to not confuse your reader. So you want to throw a comma there. You want to throw a comma there anyway. Great. All right. So let's make our enumeration. So we'll say this is an enum. We'll give it all the classic derives. And we will say inside of this enum is all of our fields. These do need commas, obviously, so we'll make sure we put the commas in there. Great. We can put this macro out here. And then let's say we want, here's a direction enum, which has up, down, left, right. Yes. So the error messages you get on macro expansions sometimes are not as helpful as you want, but usually you can still figure out what it's saying. So this one is saying name is still repeating at this depth. What that means is that at this level, right here at the top level, we've used name, but in our input, we said the name is repeating somehow, right? So our depths are mismatched, and the context system that figures out what repetition we're using says, oh wait, this needs to be repeating somewhere, which is a very easy fix. Great. Another thing you'll find with macros is that often Rust format doesn't love them because, again, macros do not operate on Rust syntax. They operate on token trees. And your input grammar, or even your output, could have any kind of arbitrary grammar you want, which means that the Rust format, except in very conservative cases, will not try to format your macros. So you have to be a little careful to do it yourself. So here's our enumeration, but let's do more, right? Let's throw a function on there that just prints out which variant we are. Great. So you'll see here, obviously, that we get to so I think we saw this earlier with the counting question, but basically we can repeat more than once. We can reuse all our repetitions anywhere we want to. So we can say we're going to match self, and we're going to say if it's $name, let's make sure we repeat it. We're using that same trick we saw before, where we get to we can reuse outer variables in inner repetitions. So we'll say $name, $field. And our output is going to be a very, very useful macro. You want to keep this one in your pocket. This is called Stringify. All that Stringify does is take some tokens, right? Because we know that macros always operate on tokens. It takes the tokens, turns them into strings. Whatever they are, they're strings now. So if I say this is $field, and I remember to put a comma in here, and what are we mad about now? Oh, yeah, because we got rid of the greetings macro. There we go. That's the problem. No, still upset? What are we upset about? Missing match arm. Sorry, guys. Bear with me. Oh, there we go. It was just stuck on something. Oh yeah. So you'll get all your standard warnings, right? This is telling us that we've created a function here that's never called, which is fine. Let's make another one. Let's say this is turn, and we'll say left or right. Great. So this all compiles. It gets mad at us again because we haven't used any of this stuff, and Rust wants us to use everything we write. But if we expand it, we can see it's generated our match here, and it's created strings out of all of our enum variants. Right. So this is the very, very, very common things that macros can do. When you have some kind of type that is very verbose, that has a bunch of very very boilerplatey, repetitive repetitions of things, a macro is a very easy place to turn to trim down what it is that you're defining. All right. So I have a few more topics here. How much time do we have? 15 minutes. Any questions at this point? No? Excellent. All right. One of the things you'll see thrown around a lot when talking about macros is something called hygiene. In my experience, my personal experience, hygiene ends up being very unimportant. It just doesn't come up that often. But it's important to know, just in case. Hygiene refers to the property of macros where identifiers introduced by the macros do not conflict with identifiers outside of the macro, right? So let's say we had some kind of very boring macro that prints something. Print, and we'll say this takes some kind of value, and we always want to be an identifier, right? Just because we're going to print it. But what we're going to say, though, is we are actually going to introduce a new variable, right? Let value equals hello. And let's print it. Println. Okay. If we call this, right, you can kind of see that it's just gonna print hello and then whatever we give it, right? So if we put let oops, let's do the actual macro. Okay. If we run this, hello world, right? The trouble that you might have noticed, though, what if this is value, right? What if this variable is called value? Well, when we expand the macro, we see that we have now doubled this variable, right? We see value is here, but it's also here, right? So if we had written this out by hand, we would have seen that it just prints out hello, hello, right? Because it's using value here, and this token gets replaced with the variable called value. But when we run it, we're going to see that it actually does the correct thing. Hello world. This is hygiene. So hygiene is the macro is smart enough to know that this value, this variable called value, is different than this variable called value, just because of where the variable exists in the source code. This, as you can imagine, is very, very, very useful and very important. It means that as you're writing macros, when you're writing a macro like this, you can be confident that whatever you are given as input is not going to conflict with whatever sort of utilities you've written inside of the macro. What this means, though, suppose you wanted to have a macro that is what we call closure-like, where it is repeating some kind of operation several times, right? So let's say we have 0 to 10, right? And we want to run some closure from 0 to 10. In order to run the closure, we have to actually tell it what identifier is going to be used in the expression, right? So we'll say here's our index, right? $index is an identifier, and then we'll take an arrow, and then we'll take some kind of expression block, right? And then here we'll write something very simple. We'll write 0.10 for each. Here we're going to use $index, which we know is an identifier, so we can put it here safely, and we'll evaluate our block. If we now call this 0 to 10 index, and we'll say we're just going to print, we'll add 1 to it. Right, so this is going to run. We're going to see 1 through 10. Great, we like that. And what's happened here, though, is that we've matched this identifier this arrow, and this expression. The hygiene rules let the macro knows because of hygiene rules that this index is the same as this index because they appear in the same scope here. This means you can't do magical things, which is good, right? There's no way we could have done this and just had index magically be the variable, right? And have an index here. This is going to say that's bad because this index is different than this index, right? So you can't have some sort of magic variable and just say to your caller, use this magic variable. Now, the trouble with hygiene is that it only goes so far. It turns out that it is really only useful for variables like this. Rust macros are somewhat leaky, and especially they are leaky with item definitions. So if you're using a macro to create an enumeration like we did here, or to create a function, the name of that function is not subject to hygiene and will leak out. So one of the common things you use macros for is making test cases. So let's say we wanted to have a macro that just generates an equality test case. So test case equal, and we'll say we're looking for a $LHS as an expression, $right-hand side is also an expression. We're going to create a new test function. We're going to call it test things equal, and we're just going to run our assertion. Great. So if we invoke this to see if 1 is equal to 1, oh, my button's not here. That's funny. So we can run a test up here. No? All right. Well, you'll take my word for it. So this, what we've done here is we've made a function called test things equal that does this equality. Once again, assert equal is a macro, so we're going to see the exact definition of assert equal. But we can see what's important here is that we've made our function. Now, the problem is, if we do this again, even though strict hygiene rules say this should be fine because this identifier should be different, that's not what's going to happen. What's going to happen is that this is going to say, no, don't like that. We have a duplicate function, right? So hygiene only gets you so far, right? Hygiene is really only useful for making these expressions. In this case, we would actually need to ask our user for an identifier to name our thing with. So, right, so this is test ones. This is test twos. And then we have to actually use it. Let's not forget that. Great. So it's annoying. That's sort of how it is, right? Here's our test ones function expanded. Here's our test two function expanded, etc. All right. That covers the bulk of it. Was there anything else?
Nathan, can you go back to your enum example for a second?
Yeah.
I do have a question about it.
Sure. I can close this out. There we go.
So I don't understand why on line 70 and 73 you need to have that the $, like I get where you're because aren't you already iterating over all the names on line 61?
So we are iterating over all the names, but now we have to iterate over all the fields, right? Because we have nested our repetition. We've said we're having several names, and then for each name we have several fields.
Oh yeah, okay.
So down here we have the same thing, right? We're repeating, and for every name we generate this whole block, and then we repeat our fields here, and we also repeat our fields here, right? So the name is copied on every iteration, right? If we actually look at this expanded, if we actually look at the call of it expanded, let's put it back. Simple enum. Right, so let's say we have our direction, which can be up, down, left, right. Let's say we have our turns, which can be left or right. And let's remember to put our exclamation point in there. Great. So if we expand this, right, we repeated our field, right? We repeated left and right, but we've duplicated our name, turn and turn, on both cases.
Gotcha.
Make sense?
Yep.
One of the sad things about this place is that this is a read-only buffer. I can't do anything with this. which is a shame because we'd like to be able to Rust format it. So sometimes you have to just kind of do the silly thing, copy paste it here into the real editor, and then it'll format it all for you. Anything else? 5 minutes left? No? All right, cool. Dave, are you unmuted?
I was just unmuting to kind of find an entry point where I can just say this was tremendous. Thank you so much for taking us through this.
My pleasure. I hope it was helpful. Like I said, I will send out the slides to everybody. You can see that I have all of these slides that I did not show that are covering all the same things that I talked about with highlighting. So you'll be able to peruse those at your leisure.
I think this was the best intro to macros I've ever seen, to be honest.
My pleasure. Obviously, feel free to come to me with any other questions. I really do like macros, as anybody who's reviewed my MRs can attest to. So I just think they're neat. Yeah, thanks everybody.
Thank you,
Have a
Nathan.
good rest of your Tuesday.